Level 0. Rain is falling, you barely register it. That is exactly the problem with thunderstorms. They happen constantly, everywhere, all the time, so the brain files them under routine and moves on. But the storm making that rain is releasing more energy than a nuclear weapon. The machine running above a city right now is a cumulonimbus tower, stacked 15 kilometers into the atmosphere, running updrafts at 160 kilometers per hour, building charge separations of hundreds of millions of volts between its upper and lower halves, and periodically discharging those separations as lightning at one-third the speed of light. The thunder is just the shock wave. Air expands violently around a channel of superheated plasma. It arrives after the flash because sound lost the race and was not even close. Roughly 40,000 thunderstorms are active on this planet right now. About 2,000 people die from lightning every year. The United States alone sees roughly 100,000 thunderstorms per year, around 10% of which are severe enough to produce hail above 2.5 centimeters, winds above 93 kilometers per hour, or a tornado. 10,000 severe storms in one country per year. Most of them disappear from the news cycle before they finish happening. What makes the thunderstorm genuinely significant is not what it does at its most common. Updrafts in a severe thunderstorm can exceed 240 kilometers per hour in the vertical column. When that column begins rotating, when the wind shear in the atmosphere is aligned in exactly the wrong configuration, the storm stops being a rain event and starts manufacturing something else entirely. And it is running at full capacity somewhere on Earth every single second of every single day. The first thing it manufactures falls quietly, bounces once, and has been killing people since long before anyone thought to take it seriously. Level 1. 10 billion euros in insured losses per year. From hail. Nobody tracks hailstorms on weather apps with the anxiety reserved for hurricanes. Nobody evacuates due to hail. It falls, either damages things or it does not. And then it stops, which is precisely the framing that lets it extract that much money from the built environment annually without generating any proportionate level of concern. Inside violent updrafts, a raindrop sweeps into freezing altitude, coats itself in ice, and starts falling. The updraft catches it. Back up. Another coating forms. Each circuit adds a concentric shell. Cut a large hailstone in half, and you see the complete record of every trip it made. Alternating rings of translucent and opaque ice, stacked like geological strata inside a frozen sphere the size of your fist. Standard hail runs about 1 to 1.5 centimeters across. The largest hailstone ever recovered in the United States fell in Vivian, South Dakota on July 23, 2010. 20 centimeters across, 878 grams, dropped from 5 kilometers up. At that mass and fall distance, terminal velocity is not a weather statistic. It is a ballistics problem. Moradabad, India, April 1888. A hailstorm killed 246 people. No tornado, no flooding, no catastrophic wind. Ice falling from the sky on a regular afternoon. The hailstorm drops, bounces, and eventually melts. What comes next does not melt for weeks, and it does most of its killing before anyone realizes the scope of what has happened. Level 2. Rain falls. The temperature sits just below 0 degrees Celsius. Rain contacts a surface and freezes on impact. By morning, the world has been laminated from the outside in. Every road is a continuous sheet. Every power line wearing a sleeve of ice was never designed to carry. Every tree now holds a load its branch structure was not engineered for. The trees do not bend under it. They crack straight through. Then the lines they were leaning on. Then the transmission towers those lines connected to. Each centimeter of ice accumulation loads approximately 500 kilograms onto every kilometer of power line. January 1998. Quebec and Ontario. 5 consecutive days of ice. Over 100 millimeters of accumulated freezing rain in some areas. Around 4 million people lost power. Parts of rural Quebec went 33 days without electricity in a Canadian January. 35 people died, many of them from carbon monoxide poisoning, after running improvised heat sources inside sealed homes. The economic damage exceeded 5 billion Canadian dollar. Repair crews arrived at roads coated in the same ice that had just dismantled the grid. There was no route in, which meant there was no fix. The only option was to wait and try to stay alive until someone could reach you from the outside. 33 days. That is not a weather inconvenience. That is a sustained survival situation inside an ordinary suburban home in the middle of a North American winter. If the ice storm is a slow siege, what comes next is the opposite of slow. Level 3. The meteorological definition of a blizzard contains no mention of snowfall totals. Sustained winds of at least 56 kilometers per hour, visibility under 400 meters from blowing or falling snow, both conditions persisting for a minimum of 3 consecutive hours. A storm can dump a full meter of snow and fail to qualify. Another can deposit almost nothing and meet every threshold because the wind is driving existing ground snow horizontally across open terrain. At 56 kilometers per hour, snow does not fall. It moves laterally. No horizon, no ground-to-sky contrast, no directional information of any kind. People have circled within 50 meters of buildings they knew were right there and failed to locate them. Frostbite on exposed skin in under 10 minutes at wind chills below minus 30 degrees Celsius. January 12th, 1888. The morning had been mild enough that children across Nebraska and the Dakota Territory walked to school without heavy outer clothing. Temperatures fell 30 degrees Celsius in hours that afternoon. The school children's blizzard killed 235 people. A significant portion of them children caught in the open when the whiteout arrived from a sky that had looked manageable just hours earlier. The pattern that emerges from historical blizzard fatalities is not about wind speed or snow depth. It is about the decision made before the storm arrived. That assumption is doing more of the killing than the temperature is. The blizzard freezes a place and holds it motionless. What comes next takes the land out from underneath it and hurls it sideways. Level 4. The sky goes brown first, then taller. By the time it becomes obvious that what is approaching is a solid wall of airborne soil 1 kilometer from base to crest, moving at 100 kilometers per hour across flat terrain, the window for decisions has already closed. A haboob forms when a thunderstorm's collapsing downdraft hits dry, flat ground and spreads outward as a fast, cold outflow pulse. That pulse scoops up millions of tons of loose topsoil and drives it forward as a wall that travels far ahead of the storm that created it. The storm is behind, the dust is already at your location. Phoenix, Arizona, July 5th, 2011. Roughly 160 kilometers wide, over 1 kilometer tall. A metropolitan area of 4.5 million people went to near zero visibility in minutes. April 14th, 1935, Black Sunday. An estimated 300,000 metric tons of topsoil stripped from Oklahoma and the Texas Panhandle in a single afternoon. Dust was deposited on ships 500 kilometers out into the Atlantic. A pulmonary condition called dust pneumonia killed over 7,000 people that decade. Roughly 3.5 million people left the region permanently, driven not by any single storm but by the land losing the structural capacity to sustain them. The dust storm relocates pieces of a place to somewhere else entirely, but it still has an outer edge, a point where the outflow loses coherence and dissipates. The next entry on this list has no such boundary, and at its full scale it generates distinct weather systems operating inside its own circulation. Level 5. No instrument has successfully measured wind speed inside a violent tornado and returned data. The instrument either misses the tornado or the tornado removes it on contact. So the scale reads wreckage and works backward to the forces required to produce that specific pattern of destruction. The bottom tier sits at 105 to 137 kilometers per hour. Snapped branches, gutters torn free, shallow-rooted trees tipped over. About half of all confirmed touchdowns are here. Dangerous and recoverable. Then the scale accelerates. 178 kilometers per hour, mobile homes overturn. 266 kilometers per hour. Well-built houses sustain major structural damage. Trees stripped of bark by wind pressure alone. 322 kilometers per hour, houses removed to foundation slab. Vehicles become airborne. Joplin, Missouri, May 22nd, 2011. On the ground for 38 kilometers, 1.6 kilometers wide at peak. 158 people killed, over 1,000 injured, 45 minutes. The public had received a 24-minute advance warning before it touched down. March 18th, 1925, the tri-state tornado. 695 people killed along a continuous 352 kilometers of ground track, crossing 3 states without ever lifting. Estimated peak winds near 480 kilometers per hour. The storm appeared at a town, destroyed it, and was gone before anyone could send word ahead. Not a failure of technology, an absence of it. Joplin had 24 minutes of warning. 158 people still died. If that is not enough time, what amount of warning actually would be? Level 6. The official wind scale measures exactly one variable: sustained wind speed. Not storm surge, which historically causes more deaths than wind in most major landfalls. Not rainfall accumulation. Not the system's forward speed. This context matters because the most lethal tropical cyclones on record inflicted the majority of their casualties through the things the scale does not account for. 119 to 153 kilometers per hour. Power outages, roof damage, downed trees. Dangerous, survivable. 178 to 208 kilometers per hour, the major hurricane threshold. Storm surge begins competing with wind as the primary cause of death. Affected areas can remain functionally uninhabitable for weeks, up to 251 kilometers per hour. Widespread structural roof failure. Hurricane Harvey made landfall in Texas in August 2017 at this tier and then stalled. 4 days parked over the Gulf Coast. Houston received over 1,500 millimeters of rain. Approximately 127 trillion liters fell across the region in under 100 hours with no mechanism for routing that volume away quickly enough. Above 252 kilometers per hour, no ceiling exists. Typhoon Haiyan struck the Philippines on November 8, 2013. Sustained winds near 315 kilometers per hour. Storm surge at 7 meters along parts of the coast. Over 6,300 people died. The structures were erased. The land where they had stood was cleared. The current scale was written to describe the storms that existed when it was written. What is the strongest tropical cyclone this planet is now capable of producing? Nobody has a settled answer, and the question itself keeps getting harder to bound. The tropical cyclone is a heat engine running on open water, and it stops the moment that water disappears beneath it. What comes next needs no ocean, no moisture, no favorable conditions of any kind. It only needs fuel, and in a dry year, an entire landscape qualifies. Level 7. It begins as a wildfire. Then the fire gets large enough to stop being governed by weather and starts generating its own. A firestorm is not a fire with strong winds. It is a fire that has grown hot enough and wide enough to create a self-sustaining convective column, pulling air inward from every direction simultaneously. Surface winds rush toward the perimeter at 50 to 140 kilometers per hour to feed oxygen into the interior. That inflow accelerates combustion, which intensifies the column, which draws in more air. The fire is no longer spreading. It is inhaling. Core temperatures exceed 1,000 degrees Celsius. Radiant heat kills people and ignites structures before the flame front arrives. An evacuation route cleared 20 minutes ago is blocked by the time the vehicle reaches it. Hamburg, Germany. July 1943. Allied bombing runs ignited multiple fires simultaneously. Estimated winds of 240 kilometers per hour pulled people through streets toward the center. Roughly 37,000 people died in 3 days. First responders could not approach the perimeter because the inflow winds pushed them back. Lahaina, Hawaii, August 8, 2023. A downed power line in drought conditions. A historic town of 13,000 people was largely erased in under 2 hours. 100 people were confirmed dead. Many were found in cars on roads the fire had surrounded before the vehicles could clear the perimeter. There had been no warning sirens. The firestorm cannot be fought from the inside. The only viable strategy is to not be within its perimeter when it locks. Once that threshold is crossed, the question stops being about suppression and becomes purely about time and distance. What comes next does not need drought, wind, or accumulated fuel. It does not need a season, a forecast, or a warning. It does not need anything on the surface at all. The energy source is already there, several kilometers below the ground, and when it finally moves, it does not ask permission from the atmosphere. It rewrites it. Level 8. There is no meteorological trigger for this storm, no warm ocean surface, no moisture-laden air mass, no cold front. The energy source is a volcanic eruption, and the thunderstorm it generates is not a secondary effect. It is a direct product of the column itself. When an eruption drives a plume of ash, gas, and fragmented rock above 20 kilometers into the stratosphere, charge separations build between ascending lighter particles and heavier material dragged downward. Lightning discharges follow, not occasionally. Continuously at rates that can exceed several hundred strikes per minute. April 1815, Tambora, Indonesia, the largest volcanic eruption in recorded human history. The immediate death toll was approximately 10,000 people. The climate disruption that followed caused 1816 to register as the coldest year in recorded Northern Hemisphere history. An estimated 70,000 to 80,000 additional people died from famine and disease in the months that followed an event most of them never saw. January 15th, 2022. Hunga Tonga Hunga Ha'apai erupted in the South Pacific. The eruption column reached 57 kilometers into the atmosphere. It generated over 400,000 lightning strikes in the first hour. The pressure wave circled the globe twice. The eruption lasted roughly 11 minutes at peak intensity. 11 minutes produced a shockwave that crossed every ocean. The volcanic thunderstorm is the only storm on this list that requires no atmosphere to initiate. It creates atmospheric conditions that did not exist before the eruption began. It is not a weather event layered on top of a geological event. It is both simultaneously, sharing the same column of superheated gas and rock rising toward the edge of space. No warning system predicts its occurrence with meaningful lead time. No shelter rated for conventional storms is rated for what surrounds it. The storm ends when the eruption ends on its own schedule for its own reasons.